Hello everyone! Today we will continue our exploration of bivariate data. Specifically, we are going to talk about outliers and influential points. Outliers and influential points are crucial when we talk about regression lines, and some basic understanding of residuals is required to fully understand them. So I will recommend you to watch the previous videos in the Bivariate data playlist if you haven't yet. Then we will move on to our actual content today. Let's start with regression outliers. Visually, we observe that in this graph over here, there are two potential outliers in the scatter plot. However, in order to legitimately classify them as outliers, we need to look at their residuals. First, we come up with the equation for the regression line. Using the equation, we can then calculate the residual for each point. To save some time, I have already calculated them, but I encourage you to try them yourself. You can reference our video on residuals if you get lost. Then we calculate the outliers for the residuals. If the residual for a certain point is an outlier in the set of residuals, the point is an outlier. Please watch our video titled Measures in Distribution Spread to learn more about interquartile range if necessary, because our first step is to calculate the interquartile range, which in our case is 1.3. because Q3 is 0.8 and Q1 is negative 0.5. Using this information, we use the formula for outliers and find out that any point with a residual larger than 3.55 or less than negative 2.96 is an outlier. Now we go back to the two potential outliers. The one at the right corner has a residual of 3.14. It is less than 3.55, so it is in fact not really an outlier. On the other hand, the other candidate is indeed an outlier because its residual is negative 3.25, which is less than negative 2.96. Next, we will talk about influential points, using two scatter plots as examples. Influential points are points whose removal would sharply change the regression line. Intuitively, you might think that all influential points have large residuals, but it is not necessarily that way. Take a look at our examples here. In the left scatter plot, we will remove this point that lies far away from the regression line, while in the right graph, we will remove a point that lies rather close to the regression line. The white lines are the regression lines after the removal. In the left graph, we observe that the regression line is only shifted slightly upwards as the result of the removal. For the right graph, however, the removal caused the regression line to rotate for a relatively large angle. Thus, we can conclude that even though the point in the right graph has a smaller residual, it has a larger impact on the regression line than the left one. Recap time. We talked about outliers and influential points in this video. We are now able to mathematically classify our regression outliers using its residual. In addition, we showed that influential points don't necessarily need very large residuals to have great impacts on the regression line. I hope you enjoy our learning together, and see you soon.